All right, so the math deal here, and today we're going to talk about the chain rule, right? We've been through all these other rules, so now let's focus on the chain rule. Chain rule gets people all the time, but I think if you can just remember, you're basically looking at the composition of two functions. So in other words, if I have two functions that are tucked inside of each other, and your job is to find the derivative, basically I'm going to take the derivative of the outer function and hold that base. Don't mess with g, okay? Then I'm going to take the derivative of g, and that derivative of g is g of x. Fair enough? So some people like to refer to this by saying it's the outer derivative, the outer function's derivative. I know I'm sloppy, but you're probably used to that by now. And then this one is the inner derivative. Okay, and that's really what the chain rule is. And chain rule comes in all shapes and sizes. So let's kick out some examples. Let's just say y is equal to, I don't know, cosine of 5x, all right? For starters, think about this as two functions. You really do have two functions here, okay? So h of x really is the composition of both of these functions, meaning f of x is the cosine function, and g of x is 5x. And when I compose the two, you remember the composition of functions, one would get tucked inside of the other, and then lo and behold, Merry Christmas, you have it. So to find the derivative, you're basically going to follow the rule. The rule says find the derivative of cosine. The derivative of cosine is negative sine. And notice I'm preserving g of x, like I'm not messing with g of x. G of x is staying here. Then I take the derivative of 5x, which is 5. And now when I kick all this out, I get negative 5 sine of 5x. And notice I just used that commutative property. Nothing but a heartbeat, right? The commutative property just pops that 5 out front and nothing but a heartbeat. Okay, I know. You're like, all right, that one's so bad. I'm going to pause the video and I'm going to check it out. Now let's do another one. I know. Let's say y is equal to negative, I don't know, 5 sine of 3x. Are you scared? You're not scared because you already watched the derivative of e to the u. Remember, derivative of e to the u is, in fact, e to the u du dx. So here we go. I end up having e to the u, right? We got to hold on to that whole function. But now I'm going to take the derivative of this function. And this function is the composition of a function. I know, right? Too many words, functions. Derivative of 5 sine 3x is 5 cosine 3x. And of course, the derivative of 3x, because there's another function in there, is 3. So, whoa, holy mackerel, what are we talking about here? We have a lot going on, don't we? Y prime ends up being 3 times 5, which, oh, by the way, I guess I can call 15. That was fun. Cosine of 3x e to the 5 sine of 3x. And there it is. That is the derivative of all that busyness. All right, go ahead, pause the video, rewind it, do what you have to do. I'm okay with that, right? And let's try one more problem. So let's say we have y is equal to the cosine of 4x squared minus 3. And let's say the whole thing has been cubed. So I have the cosine cubed of 4x squared minus 3. For starters, please, please, please recognize that that's really saying 4x squared minus 3 and the entire thing raised to the third power. So for starters, you got to remember that. Not remember that, you have to know that. I wouldn't say remember it, because why would you remember it? You might not have ever seen that before. But you want to recognize that they're the same thing. So here we go, y prime. I got a power rule. 3 is coming down in front. I'm left with the cosine 4x squared minus 3. Remember about the power rule, right? It's going to weaken the power by 1. The base stays the same, though. Don't mess with that base. Then I take the derivative of cosine. The derivative of cosine, we all know and love to be negative sine. Fair enough. Then I'm like, okay, well, I'm not done yet. I still have to take the derivative of the argument. Derivative of the argument is 8x. Holy mackerel, what do we got? We got a negative 1, we got an 8x, and we got a 3. Well, that's going to be negative 24x. That was fun. And then I have the sine of my argument. Notice my argument did not change, did it? All right. And then, of course, I have cosine squared of 4x squared minus 3. So a few things you might want to just recall, that when you have a function, a trig function squared, I can also put the 2 right there on the power. All right, I think we've done enough of these chain rules, okay? This is the math dealer signing out. Hope you do well.